Guys, so this is our lesson number 1 of the week, our first lesson of the week out of 2, and it's week number 8. Can you believe it? And this is our 8th week to have to do this. Hopefully we won't be going into too many more weeks. We'll be back in the lab. That is the hope. Anyway, it's looking good so far. That'll be the case. We'll be back after Easter. Anyway, what we're going to do is we're going to carry on. We're going to try and finish off this theory. We haven't got an awful lot of it left, which is great. And it'll leave us in a nice position then to work on lots of fun practical stuff, so we can give you a good feeling about science as you finish off your first year. Okay, so the good part is that we've done most of the stuff that you're going to need for your summer exam. And you see there on the left hand side, it's all there in the folders: 1, 2, 3, 4, 5, 6, 7, and a new folder for week 8. So last week we looked through elements, compounds, and mixtures. Okay, we did it twice actually. We did it in the live lesson as well. And then I gave you these questions, all in the periodic table, and elements, compounds, and mixtures, and solids, liquids, and gases. And I had a look at the folders there before I started this, and most of you have it up there, and that's fabulous. And a lot of you have stacks of homework up there now, and it's all corrected. You've corrected it yourself and everything, and it's brilliant. So I am going to correct this in our live lesson on Thursday, right? So just so I can get to type it in, so it's a bit interactive. Or Wednesday. So our we'll correct this in a second. So basically our live lesson later on in the week is going to be correction. So we're going to correct a lot of these questions here, and we're going to correct the questions from today. So after today's lesson, you'll have, so in our week 8 folder, you'll have a couple of questions down here at the bottom. So that'll be your homework for today. But we'll get to that in a few minutes, okay? After we go through the few bits. Now, today's lesson is about this stuff, solutions. So making up solutions. And you might not know the word. You might know the word. But you've made loads of solutions already. And you've already formed crystals. Remember the crystal experiment? You got the blue stuff, put it into the water, and you made crystals. Yeah, so this is the notes around that. So we did the experimenty part already, and this is the notes. So we can ask you this in the exams around making crystals and so on. Okay, so I'm just going to go on the iPad as well and change it so I can write. So a couple of the terminology around that. If you take a water, we say, is a great solvent. A solvent means that you can dissolve loads of stuff in it. So if I want to dissolve, if I have a teaspoon of salt, I can dissolve it in water because it's a great solvent. If I have a teaspoon of sugar, I can dissolve it in salt because it's a great solvent. I can dissolve it in water because it's a great solvent. If I have stuff that you use to make these crystals, that blue stuff, it was called copper sulfate, I can dissolve it in water because water is a great solvent. So a definition that you need to know: a solvent is a substance that dissolves other materials and makes a solution. So basically what you get is something like this. If you have salt and water, you get salt water. Lo and behold, if you add salt and water, you get salt water. But the salt is a stuff called a solute. So a solute dissolves in a solvent to get a solution. So if you look at it again, a solvent is a substance that dissolves other materials to form a solution. So your solvent in this case is the water. Okay. Now, and here's the terminology. I kind of put it all together for you there a second ago. But the substance that dissolves is called a solute. Things like salt, sugar, they're all solutes. The liquid is the solvent. A good example is water. Now, I'll do other solvents with you later on back in the lab, but the one you need to know, the main solvent that we use is water. That's a great thing to dissolve things in. And when you have then a mixture of a solute and a solvent, we call it a solution. And the example I give you here is sugar dissolves in water to form sugary water. And I gave you the other example up here, that salt dissolves in water to give you salt water, and that's a solution. Okay, so if something does dissolve in water, we say it's soluble. If something doesn't dissolve in water, we say it's insoluble. So I had to put those together in some sort of a maths equation. So basically, dissolves means soluble. Won't dissolve is insoluble. So basically, if I'm thinking something that's insoluble, so if I was to give you a beaker full of sand and a beaker full of water, and I said, listen lads, will you pour the sand into the water and give it an old stir? Well, you could stir and stir until your arm fell off, and that's not going to dissolve, because stuff like things like sand, it's in the wording, is insoluble in water. You can stir and stir and stir and stir and stir, and that's really good, because every time the wave came in off the beach and landed on the sand, it'd dissolve all the sand. You'd never keep a beach there. So sand is insoluble in water. The stuff you used to make the crystals was this stuff called copper sulfate. It's a good anti-fungi, so you can spray it and it kills mushrooms and mold and yeast and things like that. And when you add something like that, so copper sulfate to water or salt or sugar, kind of people can say, use the word, it disappears, it vanishes, it goes. It doesn't. Because if I pick up a beaker of sugary water, even though you don't know the sugar's in there, you can taste it. So you can taste the salt or you can taste the sugar. So they're not totally gone. Right, moving on. This is something different altogether. As opposed to a solution, you can have a thing of a suspension. And a suspension is things like small solids suspended in a liquid. So they're just sitting there inside the liquid. So we'll give you a good example of a suspension. I think this is one of the questions for homework, is milk, which is basically cream suspended in water. Milk is a good suspension. Calpol is a good suspension. So if you have a bottle of Calpol and you take it out of the press because you have now a sore tummy or something like that, and you want to take a thing of Calpol, it'll always say, give this a good shake, because all the solids will go to the will fall to the bottom. So what's going to happen is you have to give it a good shake to resuspend, so to redistribute all the different parts of the Calpol throughout the bottle. Okay, you remember this. I gave you a beaker of water, I gave you a spatula, I gave you something to stir with, and what you did was you had the blue copper sulfate. So you had the blue copper sulfate, that's the solute, and you chucked it into the water and it dissolved, and I got you to give it a good stir and stir and stir and stir and stir, and then I got you to heat it up, and then I got you to add more in, and what you were trying to do is get as much copper sulfate in as possible when you were making crystals. Right, and what you had at the very beginning, when you added in 1 teaspoon of copper sulfate, you had a thing called a dilute solution. So you only had a small bit of copper sulfate. It was kind of a pale blue colour. So there was a small amount of solute. In this case, the solute is the copper sulfate in a large amount of solvent. So it was light blue, you had a small bit of copper sulfate in the water. And then what you did was, you kept adding copper sulfate. You put it on the hot plate, you warmed it up, and you made a concentrated solution. And then at that stage, you had loads of copper sulfate, so lots of solute, which was your copper sulfate again, in a small amount of solvent. So the water was starting to leave, evaporate and boil off. And you had really dark blue. So when you're talking about copper sulfate, this would have been your light blue. And then it turned into a really dark royal blue colour. So this is going to be dark blue as it becomes more concentrated. If you think of a bottle of my waddy, and in here, in the actual bottle, this is going to be really concentrated, really dark orange. If you poured a glass of that now and took a drink, it'd be super sweet, super strong. And that's why we don't do that. We add a little bit in to a glass and top it up with water. So what we're doing is, you say, well, what are we doing with it? Well, we're diluting it. And we're diluting it because we're making a diluted solution. And what you were doing with the copper sulfate experiment is you were going from a diluted solution and you were making a more concentrated solution. So usually with my waddy, we're going from the concentrated to the dilute. But when you were doing the copper sulfate experiment, you were going from the diluted to the concentrated by adding more copper sulfate and taking out the water by evaporation or by boiling. So a crystal then, what you were trying to make, a crystal is a solid. So obviously it's not a liquid, it's not a gas. And the particles are arranged. So that's why you get this nice regular kind of crystally glassy substance at the end. The last type of solution, so we have a dilute one, a concentrated one, and this is what I was trying to get you to make. So this one here, and this is why you do it, just make it a bit smaller, to produce crystals. What I was trying to get you to do was make a saturated solution. You think of the word saturated. You know, you're wet in the rain and you get so wet that you can't possibly get any of your wet. Everything's wet. Your jeans are saturated, your jumper's saturated, and you're completely soaking. And what it means is it contains as much dissolved solute as possible at a given temperature. So I said to you, right, I want you to heat that up to just under 100 degrees. So I want you to get it really, really, not 100%, 100 degrees. And you heated it up on the thing. And as you were heating it up, you put as much as you could. You spooned in as much copper sulfate as you could. And remember, I always said to you, as you're spooning it in, make sure it's dissolving. So add it, stir, add, stir, heat it, keep heating it and adding and stirring and heating. Don't put too much in because it has to be dissolved at a given temperature. And when you make a saturated solution, so here's a sponge here, so that has as much water as humanly possible. And when we were doing copper sulfate saturated solution, here it is here. So we said it was saturated when no more copper sulfate would dissolve at that temperature, and our temperature was really hot. And this was the danger. This is what I didn't want. I didn't want you to get it really, really hot and keep adding copper sulfate, and you don't want a powder at the bottom. You don't want undissolved copper sulfate because then you just get like some of you did get, a big powdery wet mess of stuff in the bottom of a beaker. You want to add just as much as you can at a given temperature, and you remember that. Okay, nearly there. So if we want to look at solubility, so how much you can dissolve. So the solubility of something is the mass that will dissolve in 100 grams at a fixed temperature. So basically, how much you can dissolve. So let me just talk you through this, because this looks mad complicated, but it isn't. So if you imagine on your hot plate, you started off at 0 degrees, and then you heated it a bit, and you added in a couple of grams of copper sulfate. Then you heated it a bit more, and you added in another 3 grams. Then you heated it up to 30 degrees, and you added another bit. And then you heated it up to 40, and you added another bit. And you keep heating 50, 60, 70, 80, 90. And every time it got a bit warmer, you threw in an extra little bit of copper sulfate, an extra little bit, up to 47, an extra little bit, and an extra little bit. So as you go through the temperatures, you're adding in extra little bits of copper sulfate. And if you put that into a graph then, so you take the first point there, and this is just what we can ask you in an exam, graph solubility. So at 0 degrees of temperature, we're at 14 degrees. So have a look over at the graph then. So here's 0 degrees down here in the corner, and here's 14 degrees. So our first point is going to be where I circle there. The next point is going to be 10 degrees Celsius with 17 grams. So here's 10 degrees down here, and 17 is in here on the y-axis there. So here's our second point, and we go all the way along, and we can graph all those points all the way along. You see them graph, the red dots, and they graph up like that. And we join the line, and that gives us the solubility curve. So we see the curve going in that direction like that. And what that means is that as the temperature increases, the solubility increases. So temperature. So as you get warmer, you can dissolve more solute. And you remember that you could add in about 2 spoons of copper sulfate, and you were stirring, and it wasn't dissolving for you. But then once you got it on the hot plate and you heated it up a bit, you could add in more copper sulfate, was dissolving. And then once you got it nice and warm, you could add more copper sulfate. So the hotter it got, so the higher the temperature, the more copper sulfate you could dissolve in. And the definition of that is, so that graph there is called a solubility curve. And that shows how the solubility changes with temperature. So the solubility goes up when temperature goes up. And then what you did was, when you got as much in as you possibly could, I said, right, leave it on the windowsill and we'll check the next day. And when you come in the next day, now some of you didn't get it, but more than half of you did. And you got all these little crystals down the bottom, these blue copper sulfate crystals down the bottom sitting in water. That's crystallization. So it's a cooling of a saturated solution. So a hot saturated solution is cooled, and then we get crystals. That's what crystallization is. Okay, and that, when we did it with copper sulfate, you can do it with loads of different chemicals. So I'll do it again with you when we get back to the lab, and there's different color crystals and different types of crystals you can make. We just made copper sulfate ones so far. Okay, and that's it. That's what I want you to know. That's what I want you to learn. I want you to have a look over it yourself and make sure you know the definitions for a dilute solution, a concentrated solution, a saturated solution, insoluble, soluble, and solute, solvent, and solution itself. Okay, and I have a couple of questions here for you. So if you see, these are questions here. These are to be completed for lesson 2 later in the week and uploaded to the homework section of your OneNote. So before you come to our lesson to lesson 2, which is going to be a live lesson, you should have the questions from last week. So the periodic table ones, here they are here. So you should have the answers to those in the homework section of your OneNote, and you should have this week's questions in the homework section of your OneNote. And what we're going to do then is in the conference, I will ask you to type in the answers to both sets of questions, and that will be our second lesson of the week. Next week we're going to go on to our last topic, maybe second last one if I have to do. I might do one of the second year ones as well, just because I'll start to run out of ideas. We're going to go on to measurement, so measuring things like temperature and distance and time and weight. And we're going to go on to motion, things like speed, distance, time, acceleration, things like that. So there's your homework. Make sure you have last week's one uploaded from based on the periodic table, and either copy this whole diagram into copy this set of questions here into the homework section of your OneNote and do it in there if you have a stylus, or write the answers into your copy. Make sure it's clearly labeled, because I can't find some of the homework if they're all in the same folder in your homework folder. So try and make a different page every time you do a homework, so it's easy for me to find. And take a picture of your copy and stick it into the homework section of your OneNote. Okay, any questions, guys? You have my email address. Just email me anytime if you get stuck or you need a hand. And I will chat to you in lesson 2 later in the week. Mind yourselves. Have a good week. Bye-bye.